In this section, chapter 1.9, we'll be covering graphing quadratic equations. In the past, you have uncovered graphing simple equations, like linear equations, y equals 2x per se, that if you were to graph this, since there's no b, we consider this to start at the origin. And the slope can be interpreted by the coefficient in front of the variable. 2 can be represented as 2 over 1, which means we go up by 2, then over 1. And you can distinguish your line by connecting the 2 points together. So that's pretty simple. A little bit more complex equations could look like this. Y equals negative 3 halves, x minus 1, where if you were to graph this on the coordinate grid, your b, the y-intercept, starts at negative 1, and then your slope is at negative 3 halves, which means you go down by 3 this time because of the negative, then over 2. 1, 2, 3, then you go over by 2. And you can distinguish your line by connecting the 2 dots together. In this section, chapter 1.9, we'll be graphing quadratic equations and identifying the characteristics about the equations. There's so much to tell just with the parabola of the quadratic equation. So if you have a parabola like this, notice how it intercepts the x-axis at 2 points. And this is when y equals 0, you get these 2 points. It crosses the y-axis at this point, and this is when x is equal to 0. A little bit more information about this parabola is that it has a lowest point here. And this can be denoted by the formula negative b over 2a, and then the function of negative b over 2a. This is an order pair point which can be extrapolated by the standard form of the parabola, ax squared plus bx plus c. So an example that resembles this, or can be resemblance to any parabola, is x squared plus 5x plus 4. The 1 is a, the b is a 5, and the c is a 4. And due to the formula, negative b over 2a, the b is the 5, and the a is the 1. And then we start plugging in negative 5 over 2 times 1, which is just 2. So now that we have negative 5 over 2 as x at the vertex, we then plug that back in so that we can find y. So the function of negative 5 halves is equal to, and then you'll plug that in for the x values. So we'll be covering questions that uses this information. So onwards to question number 1. Our goal is to find x-intercepts, y-intercepts, vertex, interval notation of decreasing function, interval notation of the increasing function, and the function of 3. Y equals x squared plus 6x plus 8. Just like the previous slide, in order to find the x-intercept, plug 0 for y to find x-intercepts. 0 is equal to x squared plus 6x plus 8. Now, this kind of problem looks pretty familiar from chapter 1.6, where you have to actually factor out and then solve for the x values. This is a simple cross product algorithm. I'll put the 8 here, the 6 in the middle. Factors of 8 that can add up to 6, 4 and 2, due to the list. 1 and 8, and then 4 and 2. So now the parabola, simplified version, becomes x was 4 and x was 2 is equal to 0. Split, x plus 4 is equal to 0, and x plus 2 is equal to 0. And then from here, apply the inverse operation. X is equal to negative 4, Subtract 2 to both sides, and x is equal to negative 2. So these are considered the x-intercepts at x is equal to negative 4 and x is equal to negative 2. Now to find the y-intercepts, just like the previous slide, in order to find a y-intercept, we plug 0 for x to find the y-intercept. Calculating the y-intercept is usually easier than finding the x-intercept, where all you need to do is just plug in 0 in for x. Zero to the second times 6 times 0 plus 8. The result becomes 0 plus 0 plus 8, which in the end becomes 8. So the y-intercept is at 8. Now the vertex. You have recently learned that the vertex is negative b over 2a, and the function of negative b over 2a. Ax squared plus bx plus c, and this is x squared plus 6x plus 8. The 1 is a, the 6 is a b, and the c is 8. So we'll just substitute the b value, which is 6. So it's negative 6 because of the sign. Negative 6 over 2 times 1 because of the a. Negative 6 over 2 is the same thing as negative 3. Negative 3 is considered to be the x of the vertex. So now our next goal is to insert the negative 3 back to the function so that we can get our y value. The function of negative 3, I'll keep these blank, plus 6, plus 8. I will be reinserting the negative 3 and then applying the math from here. Negative 3 to the second, that's 9. 6 times negative 3 is 18, plus 8. Simplify. This is negative 9 plus 8, which is negative 1. So the vertex, let me highlight negative 1, is negative 3, negative 1. Negative 3, negative 1. So now that we have found out what the x-intercept of the function is, the y-intercept, the vertex, we have plenty of information to graph the line and then interpret it. The vertex is at negative 3, negative 1. So this is either the lowest or the highest point of the function. Let's read a little bit more about this function. The x-intercept starts at negative 4 and has the next point at negative 2. Negative 4 and negative 2. Negative 1, negative 2, negative 3, negative 4. So here's the x-intercept. And then the other intercept is at negative 2. The y-intercept is at 8. So that is this point right here. So we will need to go 8 units up, 4, 5, 6, 7, 8. And now we can make our line, or in this case, a parabola. Other pieces of information about the parabola states that we need to find the increasing and decreasing parts to the function. First, we will denote the interval notation of decreasing function. So let's find out when the function is decreasing. A function decreases when it's going down either in this manner or in this manner. In this parabola, we can see that the function is going down at this section. until it reaches the lowest point. So it starts to go down, 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 up to this point. So the decreasing function will go from negative infinity up to, and the lowest point is at negative 3. It can't touch negative 3, but it's approaching negative 3, so that's why we use the parentheses. This is considered to be the interval notation of the decreasing function. Now, what about the increasing interval notation of the function? So we will now answer the last part of the question. Interval notation of the increasing function. Which starts at the vertex, and it just goes up at this point, because the function is going upwards. So we denote this by saying that it starts at negative 3, and it goes up to positive infinity forever. And this can be seen by looking at the parabola. At the lowest point, it starts to increase, increase, increase forever. So we have the decreasing function from negative infinity up to negative 3, and the increasing function from negative 3 up to positive infinity. So be sure that your answers look like an interval notation. And now the last part of the question states to find a function of 3. The function of 3, f of 3, is equal to, and then all you need to just plug in 3 in for x. So the original question was x squared plus 6x plus 8, x squared plus 6x plus 8, and then substitute 3. Applying a little bit arithmetics. 3 to the second, that's 9. 6 times 3 is 18, plus 8, which becomes 27 plus 8, which is 35. So be sure to write your answer in this manner. The function of 3 equals 35. So this concludes all the characteristics about the function. We were able to identify the x-intercepts, where it crosses the x-axis at negative 4, negative 2. So it crosses at negative 4 and negative 2. It crosses the y-axis at 8. The y-axis is at this point, because this is considered to be the y-axis. The vertex needs to follow a special tool formula, which states that you have negative b over 2a, and then the function of negative b over 2a. So that's essentially plugging in your result of this, which we have identified earlier, which was negative 6 over 2 for the function, negative 6 over 2 times 1, which is 2, and the result of this is negative 3. Then we plug in negative 3 back into the polynomial. And this is x squared plus 6x plus 8 to give you the result, which we have calculated that to be negative 1. So that's why the vertex needs to be stated as an xy order pair point. Negative 3, negative 1 is the lowest point of the parabola, which makes sense for it to be in the middle of negative 2 and negative 4. And then we were able to interpret the decreasing function from negative infinity up to the lowest point of the parabola, which is negative 3, and then the increasing function from negative 3 up to positive infinity.